Today we are going to see the practical for SSB modulation, that is single sideband amplitude modulation. There are two methods. First one is SSB using filter method and second is SSB using phase shift method. So firstly we will see SSB using filter method. So in this method, this is the block diagram, the filter method of SSB. So the basic concept what we have to do in SSB is we have to suppress one sideband as well as the carrier. So first we will be generating a modulating signal of audio frequency. So it is called as audio signal. So it is basically sinusoidal in nature. We are generating it using audio generator. We are feeding it to the balance modulator. The balance modulator will suppress the carrier and the two sidebands will be as it is. We are also giving the carrier to the modulator to modulate the carrier with respect to this audio signal. So at the output of balance modulator we will get double sideband suppressed carrier waveform, that is DSBSC. Then we will be feeding this output of the balance modulator to the band pass filter. So the basic idea of SSB is to suppress one of the sidebands. So to suppress that, the sidebands are separated at different frequencies. That is, one is FC minus FM, that is LSB, and FC plus FM, that is USB. So to suppress one sideband we have to use a filter, and we are using a band pass filter to suppress that specified sideband. So we are going to give the output of the balance modulator, that is DSBSC signal, to the band pass filter, and we will be suppressing certain sideband. Then this will be transmitted. This dotted says the transmission line, and at the receiver side there we are using a detector, the product detector, to detect the AM signal. At the detector output we will get the original message signal or audio signal. So this is the kit we are using for SSB modulation and demodulation. So here you can see there is an audio generator, that is the modulating signal we are using. So it generates the audio generator. There are two knobs, amplitude and frequency, by which we set the amplitude and frequency of the audio signal. Here there is a RF generator, that is the carrier generator. Here there are also two knobs, frequency knob and amplitude knob. We use these two attenuators to set frequency and amplitude of the carrier wave. So basically now we will be we are going to first adjust the amplitude and frequency of the audio signal, that is the modulating signal. We are going to connect it to the CRO channel 1. I'm going to adjust the time per division and volts per division knobs to get the desired output. So it is set to 1 millisecond, the time per division knob, and voltage per division is set to 1 volt per division. So now we are going to set it. The amplitude is expected to be, now we are going to set the amplitude to 3 volt peak to peak and the frequency to 10 kilohertz. So the frequency is 9.7. The frequency knob is at its full position. So we can say okay, 9.7 is somewhere near 10. So we have set the frequency to 10 kilohertz. Now we are going to set amplitude. Now you are seeing here using graphical method we are setting this. we'll set a 3 volt peak to peak. I think it is already 3 volt. See, this is 1, 2 and 3 divisions and 1 volt per division, so it makes 3 volts peak to peak. So we have set the audio signal for 3 volts peak to peak, amplitude and frequency of 10 kilohertz. Now we are going to set the amplitude and frequency for the carrier signal. So this is the RF generator, that is carrier generator. I am going to connect it to the channel 1 of the CRO. These knobs you are going to adjust to set the certain frequency. Now here you can see the frequency is 408, so I am going to turn this knob and adjust it to 455. We are going to set the frequency of carrier signal to 455 kilohertz and amplitude to 10 volt peak to peak. You can see through adjusting this knob, we are setting the frequency to 455 kilohertz. It's stable, it's okay, 455 kilohertz. Now I'm going to set the amplitude to 10 volts peak to peak. Now basic thing is, here there are only 8 divisions peak to peak available on the CRO screen. So what I'm going to do this time is, I'm going to the volts per division, now I'm going to set it to 5 volts per division. So as we want 10 volts peak to peak, I'm setting 5 volts per division, so we would need 2 divisions that would make 10 volts peak to peak. So I'm going to turn this amplitude knob and set it to, so it's approximately, it's somewhere near 2 divisions, that makes 2 into 5 volts, that is 10 volts peak to peak amplitude. So here we have set the amplitude and frequency of carrier wave. Amplitude we have set 10 volts peak to peak and frequency to 455 kilohertz. So now we are going to make connections on this trainer kit using the connecting wires. So now I am going to give the audio generator output, that is the audio signal, to modulator 1, that is we are feeding it to balance modulator 1. And the second thing we need for modulation is the carrier signal. Now here in this trainer kit, carrier signal is fed to the modulator internally. We can see this through this line that is going to the modulator 1 here. So the carrier is internally connected to the modulator, so we need not connect it externally. I have already given the modulating signal, and the carrier signal is connected internally. So at the output we will be getting double sideband suppressed carrier. The modulator 1 only suppresses the carrier and keeps the sidebands as it is. So we are going to observe it on the CRO. So here we are seeing that at the output of modulator we are getting the DSBC, that is double sideband suppressed carrier signal. This practical we are using SSB, that is single sideband. So as the output of modulator 1 is double sideband, we need to suppress one sideband. So for suppression of one sideband we are using band pass filter. So we are going to give the output of the balance modulator to the band pass filter. And at the output of the band pass filter we are going to observe the single sideband. So on the CRO, we seeing it on the CRO. So it's not much clear, but somewhere near single sideband you can see, analyze it better in frequency domain, that is on spectrum analyzer. So using this we have suppressed one carrier. Now we are going to transmit this. So basically here we are going to transmission line. I am using a connecting wire itself. So I am going to connect the output of band pass filter to the demodulator, that is detector. Now I want to see the output of detector, the CRO. Now the detector will give us the original signal that we had applied as the audio signal. That was the modulating signal we will get after demodulation as it is originally. This was the time domain analysis of SSB. Now we are going to analyze in frequency domain using spectrum analyzer. So this is a spectrum analyzer. We are going to set some basic parameters such as frequency. We are going to set it as 455 kilohertz. This is the center frequency. So it is showing it is compressed. Now span is the separation between two frequencies. We are going to set it to 100 kilohertz. So the span is set to 100 kilohertz. Now we are going to apply the output of the now on spectrum analyzer. First let us analyze the output of modulator, balance modulator, that is DSB-SC. We are getting the carrier is suppressed and the sidebands remain as it is. They are not suppressed. Now secondly we are going to see the output of the bandpass filter, that is the when we are feeding the output of the modulator to the bandpass filter to suppress one sideband. We are now seeing it on the spectrum analyzer. So as we can see, the center frequency and one of the sideband is suppressed a little bit. USB and the carrier frequencies are suppressed and the LSB is as it is. This completes the time domain and frequency domain analysis of the SSB modulation. Thank you for watching.